Alright, hey everybody, how's it going? So we're going to continue with the next packet here. This is adding and subtracting rational expressions. So yesterday we did all that factoring of expressions that's going to come into play here. And when we add or subtract stuff. So you guys should remember that if you are adding or subtracting rationals or basically fractions, you're going to need that common denominator. So now we'll be finding common denominators, but it won't just be one number, it'll be an expression. So it'll be like x minus 5 or x squared plus 1. So we need those common expressions. We'll start with this first one. These already have common denominators. This is 3x minus 4 over x squared plus 1 minus 6x plus 1 over x squared plus 1. So since they already have those common denominators, we can just subtract the top here. When you do minus 6x plus 1, remember that the minus distributes, so it'll be 6x minus 1. And since we have that common denominator, we can combine those terms there. Let me write this in pen, because I think it'll turn out better. Just like that. Okay, so common denominator. So then we can just subtract stuff on the top. So 3x minus 6x will be minus 3x. Minus 4 minus 1 is minus 5 over x squared plus 1. And that's it. And then we need to set our domain restrictions. Here we have a restriction in the bottom. So the bottom can't ever equal 0. So I'm going to set x squared plus 1 equals 0. So then I get x squared equals minus 1. Take the square root of each side, we get x equals plus or minus I. And so the expression cannot equal plus or minus I. We'll have a hole in the graph there at that spot. Alright, so let's just move on here. The next one, again we have a same denominator here. It's 3x minus 1, so I can just simply combine the top numbers. I'll do 3x squared minus 5 minus 2x squared minus 3x, so that'd be plus 3x minus minus 2, so that's plus 2. All over 3x minus 1. I'll combine these, the 3x squared and the 2x squared combined, that gives me x squared. 3x is by itself. And then minus 5 plus 2 would be minus 3 over 3x minus 1. And then let's see if we can... I think this will be alright. I'm going to do 3x minus 1 equals 0. 3x equals 1. X cannot equal 1/3. So that's your answer there. What I was going to do was factor the top to see if I could cancel anything out. We're going to move into that with this bottom one right here. Okay, so it says to add or subtract rational expressions with unlike denominators, first find the least common denominator, or the LCD. The LCD is the least common multiple of the polynomials in the denominators. So to find the LCM, what you want to do is first factor the polynomial completely, and then list the different factors. If the polynomials have common factors, use the highest power of each common factor. Okay, so what we'll do here is I'm going to first factor this bottom here. This is x minus 3 plus 2x over x squared plus 3x minus 4 over x plus 4. I just rewrote it. I'm going to factor out the bottom here. This will be x minus 3 plus 2x. This will factor into x and x. We'll do minus 1 plus 4. That should give us this trinomial. Pause the video and FOIL this out if you have questions about that. Over x plus 4. Okay, so if you notice on the left side we have factors of x minus 1 and x plus 4. And then on the right side we only have factors of x plus 4. So to make these have the same base, just like how they were up here, it was the same base, what I'll do is multiply the right expression by x minus 1. Okay, so multiply, we're going to multiply the right expression by x minus 1 on the top and bottom. Now we have the same factors in the base. We have x minus 1 and x plus 4. So I can now combine these. So we'll do combine. It'll be x minus 3 plus, I'm going to distribute this, so 2x times x is 2x squared. 2x times negative 1 will be minus 2x over, and then this is the important part, do not multiply these, don't FOIL these just yet. What I'm going to do is combine these and then factor it and see if I can cross anything out. So let's combine this. I get 2x squared minus 2x plus x will be minus x minus 3 over x minus 1 times x plus 4. So this is, again, simplifying. Now I'm going to factor this top bit. So I have 2x and x. This should give me the 2x squared. These numbers need to multiply to get me negative 3. So let's do negative 3 and positive 1. Yeah. So then I should have positive 2x minus 3x, it gives me the negative x, and then negative 3 times 1, it gives me the negative 3. This is over x plus 4 over x minus 1. Oh, what did I do here? Looks like I was being optimistic when I did this. When I did this earlier, these were the same. Looks like I just changed it out of midair. So what do we see here? We see that we do not have anything that we can cancel. So this is done. Okay, this is done. So let's look at what numbers we cannot have. X can't equal negative 4, that comes from this. X can't equal 1, that comes from x minus 1. So this is your answer. Alright. Turn it over. Would you look at that? We have a whole lot more here. Okay. Let's keep on moving. So let's look at, we have x over x plus 2 plus negative 8 over x squared minus 4. So I see a difference of 2 squares right here, so I'm going to factor that first. So I have x over x plus 2 plus negative 8 over x plus 2 times x minus 2. Now I need to find my common denominators. Looks like the right expression has x minus 2, the left does not have that. So I'll multiply the left side by x minus 2. Now both expressions have the same base, so I can combine these. So I get x minus 2 times x plus negative 8, I'll just write that as minus 8, over x minus 2 times x plus 2. Okay, so we've combined the top, and then I'll multiply out the top. So x times x is x squared minus 2x minus 8 over x minus 2 times x plus 2. And then lastly I'll factor, so I'll factor out the top. Let's see what we get here. We got x times x. I want negative 8, so I'll do 4 and 2. If I use a negative 4 and a positive 2, that gives me that negative 2x over x minus 2 times x plus 2. Now we can cancel stuff, so these cancel, and your final result is x minus 4 over x minus 2. And let's look at our restrictions here. So x can't equal 2. X can't equal -2. And then it's important to look through your entire work here and see if there's any others that you missed. Looks like those are the only 2 restrictions that we had. So this is your answer. Alright, let's try the next one. So we have 3x over 2x minus 2 plus 3x minus 2 over 3x minus 3. So I noticed that, let's see, I can factor out 2 and 3. Let's try that. So I'm going to take out, I'll take out 2 here. This will be x minus 1 plus 3x minus 2 over 3 times x minus 1. Okay, cool. So now we have x minus 1 in both, but we have a 2 here and a 3 here. So what I'm going to do is multiply the left side by 3 and the right side by 2. When I do that, 2 times 3 is 6, 3 times 2 is 6. I'll get the same number. This is finding the least common multiple. So let's do that. So we do 3x over 2 times x minus 1. I'm going to multiply the top and bottom by 3. And then I'll do 3x minus 2 over 3 times x minus 1, multiply the top and bottom by 2. So this should give me 9x over 6 times x minus 1 plus, combine these, this will be 6x minus 4 over 6 times x minus 1. Now they have the same base, and I can now combine the expressions. So this will be 9x plus 6x minus 4 over 6 times x minus 1. So again, they got the same base here. And that's the key thing. We want the same base so we can combine them. 9x plus 6x is 15x minus 4 over 6 times x minus 1. And I'm pretty sure there's nothing here that I can take out. Yeah, 15 and 4 are not friendly. So this looks done here. Let's look at our restrictions. X can't equal 1. And if we go up top to the up here, we could set each of these to 0 and solve, but they are the same thing. You get 2 times x minus 1 and 3 times x minus 1, so the same deal here. X can't equal 1 in both cases. So this is our final answer. Alright. I'm going to stop this video. The next page is just a little bit more involved stuff. You can choose to watch it or not. It might be helpful when you're trying to complete the homework. I'll just go ahead and do it, and it'll be a resource for you so you can view. Alright.